All right, so we have sequences that we're going to talk about next, and a sequence is just a series of numbers in a specific pattern. So our first sequence that we're going to discuss is called an arithmetic sequence. And an arithmetic sequence is a sequence where the difference between the numbers is constant, meaning you are adding or subtracting to get to the next term. Okay, we have two formulas that apply to our arithmetic sequences, and we have another type that will be geometric. So we have all the formulas that will go with these. So here, the first thing is a recursive formula, and the next thing would be an explicit formula. All of these values right here tell you exactly what each part of the formula means. I'm going to use the example and explain what the formula means while I do the example. So let's start with recursive. So first off, we have this sequence 12, 15, 18. Okay, so hopefully you quickly realize to get from 12 to 15 and then 15 to 18, you are adding 3. So because I'm adding 3, that's what makes it arithmetic. And then the 3 will be what we call our D value, which is a common difference. The difference between the numbers is 3. So in this problem, our D will equal 3. Okay, so starting with the recursive. The recursive is just basically a formula that's just informative of telling you what's happening in the problem. So when you write this an and this an minus 1 stay just the same. The only thing you do is plug in your common difference. Okay, so when I go to write this formula, I'm going to just write it just like this. Not that, with a 3 at the end. Okay, and so this just now tells me this is recursive and I'm adding 3, but you must also tell me what your first term is. And when I say A1, and it tells you right here, A1 is your first term. Okay, so when you're doing a recursive formula, you always have to tell me what your first term is, which is 12. Okay, and that's all you would do as far as a recursive formula. Now, when you see the formula, all it means is there's my first term, which is 12. And then this tells me what I'm doing. I'm adding 3. So if I had to write the sequence, I would write the sequence out that way. So the first term's 12. And then you are adding 3. Okay. Now let's look at the explicit formula. The explicit formula is a little bit more useful as far as finding a specific term in the sequence. Okay, so I'm going to start with an. An will still stay an for now. Okay, then my a1 will go first. Well, a1 again means that is your first term. So the first term is 12. Now, this paper puts your common difference at the back. I like mine to be right there. It does not matter where you put it. It's just here just looks more normal and how we normally see it. So I'm going to put my common difference, which is 3, right here. And in parentheses, the n minus 1 stays n minus 1. So in this problem, like n is more so like an x value. Okay, so I'm going to simplify it now. So I'm going to distribute the 3 and get 3n minus 3. 3 times n and 3 times negative 1. And then combine like terms. So 3n will stay 3n, but then I have 12 minus 3, which will give me 9. And that's my simplified version. Okay, and now the problem here says to find the 7th term. Okay, so this is where your explicit formula is the most helpful in finding a specific term. All you do when you're trying to find a term is plug it in for n. So right here it tells you n is the number of the term you want. So if I want the seventh term, I'm going to denote that A7 and then plug in 7 for n. And so when I simplify that, 3 times 7 is 21, plus 9 will give me 30. So then my seventh term of that sequence would be 30. Okay, let's look at one more example, and then we'll go from there. All right, let's say I have the sequence this. Okay, and then dot, dot, dot. The dot, dot, dot just means it continues. Okay, so if I have this sequence, you can tell we are going down, and it's going down by 5 each time. Okay, so this means that my common difference is a -5. I'm subtracting 5, so my common difference is a -5. Okay, so if I were to write the recursive formula for that, I would have an equals an minus 1. That always stays the same. Nothing ever changes about that. And then right here, I'm putting my common difference. And since it's a -5, I'm going to put -5. And then always denote with this the first term. First term here is 20. Okay, and then the explicit. Okay, so it starts with an, and then the first part of it is our first term. So the first term is 20 plus my common difference, which is a -5. So I'm going to just put -5 and then n minus 1. The parentheses here in the explicit formula is always n minus 1. Okay, to simplify, I'm going to multiply. So -5n plus 5. So this will be -5n, and 20 plus 5 would be plus 25. And if I wanted to find let's go with the 30th. Find the 30th term. I would denote that A30. And then I would plug in 30 for n. So -5 times 30 plus 25. I got my calculator. So -5 times 30 is -150, plus 25 is -125. So that's how you would use both formulas again, with one subtracting difference and one adding difference.